So today we are going to solve this problem 474 ones and zeros. So you are given an array of binary string strs and two integer m and n. Okay, so in this problem you are given a list of string each containing only zeros and ones. Okay, each strings containing 0, ones and zeros. So two numbers m and n. Okay, so one is m and one is n. So m is equal to numbers of 0 you can use, okay, and n is numbers of ones you can use, okay. Maximum so m is maximum number of zeros you can use and n is maximum number of ones so you can use. So task is pick as many strings as possible from the list without cascading m zeros or n ones in total. So the for each string count its zeros and ones, so you can take it if there are enough zeros and one left or skip it, okay, and maximize the total number of string you pick. So let's try that. Okay, so we have string like this, string like this. String is equal to 10 0 0 1 and 1. Okay, m is equal to 5 and n is equal to 3. So first is 10. In 10 zeros are 1 and ones are 1. Okay, so in this string zeros are 2, ones are 1. Okay, in these strings zeros are zeros, ones are 1. Okay, so pick 10. So we pick this string or this. Total zeros is 1 plus 3 plus 0 is equal to 4. So total 0 is 4. No, total 0 is 3. 1 2 3. 1 plus 3 4 plus, so 4 is less than 5. So and in ones, how many 1 2 3. 1 plus 1 plus 1 is 3. So 3 is greater than 3. So this answer is true. So the answer is 3. Okay, so the answer is 3. If we have string like this, if we have string like this 1 1 1 1 1 1 and 1. Okay, so if m is 0, and n is 2, so see in string 1 is there are 3 ones, okay, there are 3 ones and zeros are not 0, there is no 0, so we cannot take this because n is 2. So 3 is greater than 2, so we cannot take this in this string. We can consider this string, okay, 1 and zeros are zeros, there is no 0 in this string, so we can consider this string. So the maximum answer is 1. Okay, only 1 can be taken, so total string is 1. So we count the 0 and 1s in each string. For each string choose to take or skip based on remaining m and n. Okay, so goal is maximize total number of strings. Okay, so let's try then. If we have string like this, so string string is 10 0 and 1. Okay, so m is 1 and n is 1. So first we count 10 is equal to 1 0 and 1 1. In string 1 to in index 1 is there are only 1 0 and 0 1. there are no ones. In index 2, in index 2 we have 1. So this is index 0 1 2. In index 2 we have only 1, so the 1, so zeros are zeros and 1 is 1. So okay, so goal is maximum strings. So let's try then. See, first level, so solve of, we call this function 0, this is index, and 1 m and n. Okay, we minus from target. Okay, considering is 10. So 1 zeros are 1 1, so if we skip this, so solve of, if we skip 1 1 1, and if we take this, solve of 1 0 1. So skip resources same, so take subtract 0 from 1s. Okay, if in level 1 or from this, if we solve this, if we consider this, if we consider this, okay, 1 0 and 0, so see, this is our index 2, solve of 2, so 1 0 and 0 1. Okay, so if we consider this, considering 0, we are considering 0, index 2 and 1 1. If we if we skip, if we take this, we call the function 2 0 1. So in skip, resources unchanged, and if we take 0, reduce. Okay, if we come this skip, if we skip 0, if we skip 0, if we skip 0, okay, considering 1, so zeros are zeros. If we skip 0, considering 1, 0 is 0 and 1 is 1. So if we skip this, so it's 3 1 1, and if we take this, 3 1 0. Okay, so solve of 3 1 1 is end, so we are going to return 0. So solve of 3 1 0, so it's end, so we are going to return 1, and here 0. Okay, so level 2 2 0 1. So in this leaf, okay, now we solve this leaf, we write here, so solve of 2 0 1, so we considering 1. Okay, if we are considering string 1, so if we skip this, solve of 3 0 1, because we can skipping, if we take this 3 0 0. Okay, now we solve, so 3 0 it's going to return 0, and this will give us 1. So because we already took 0 and add 1, so 1 plus 1 is 2. So now we solve this. Okay, 1 0 0. So solve of 1 0 0, considering 0. If we skip, it's 2 0. If we take, was not, if we cannot take because it's not possible, so so need 1 0, but m is, so we need 1 0, but m is equal to 0. So next we solve 2 0 2, considering 1. So if we skip this 3 0 0, if we take not possible, we cannot take, so here 0 signs we already took 10, so total is 1. So skip side branch become result of 2, and take branch, see, skip side branches result is 2, and take branches result is 1. So max of take and skip 2 as 1, so the max is 2. So we are going to, so the final maximum string is 2. Okay, best case is that's it. So each node represent a decision point. We either skip or take a string. So taking reduce available zeros and ones. When we reach the end, we return 0. Okay, so the maximum result is apply. So see, we have used this example. So now we write code. We have used this example 10, 0 and 1. Okay, so m is 1 and n is 1. So first we solve 0 1 1 0 1 2. Okay, so this considering 10. Okay, means we need a function with index I and remaining zeros and remaining ones n. Okay, so let's write down the function of this case. So we need function, so we need a function with index. So this is, I think, int solve. We need a function with index I, so int I and zeros n and ones in n. Okay, so and this nums to see command V. Okay, because every node in tree had I, m and n, because every tree had node I, m and n. Okay, next, if this is index 3 2, okay, 0 1 2, if we come out of bound like 3, like in this case just like 3, here we are going to return 0. For this case, see, solve of 3, index 3, and there is nothing, 0 0, so this was n, so here we are going to return 0. Okay, this is a base case. When index reach n, no string left. Okay, this means when index reach end, there was no string left. Okay, so we write a base case if I is equal to strs dot size return 0. Okay, so we have written 0. This is a base case. Okay, next, see, tree node example. If we solve index and m and n, this is 10. We need 0 counts and ones count. Okay, we need count of these both. No, this was index. We need count of these both, m and n. Okay, m is 0 and n is 1, so we need count of both. So we write int ze r 0 is equal to 0 and int 1 is equal to 0 for character c is to st alias of I if c is equal to 0 c is equal to 0 plus else 1 plus o and a1 plus, I think we like zeros, zeros, ones, zeros and ones. Okay, we need 0 count and 1 count because every node first check current string cost. Okay, next, see, next what we need, if we will be skip. Okay, we skip solve of I. See, next we'll skip, we have two options, skip or take. If we skip solve of 1 comma 1 comma 1, move next index, resource the same. Okay, for now we move next index or resource the same, and skip is equal to solve of I plus 1 yum n and strs. Next, take. See, take solve of 1 comma 0 comma 0 only when resources error, which if condition, first we check the condition, reduce 0 and 1s. Okay, first we check condition and we reduce 0 and 1, so like this. And take is equal to 0 if zeros are less than or equal to m and ones less than or equal to n. Take is equal to 1 plus solve of I plus 1 m minus zeros and n minus ones so m minus 1 next time. So see, in the we are using plus 1 because we select one string in the tree. Okay, next, tree always end with, so this always end with take or skip. We return the max of this. Here we are returning see, here we are returning this. Okay, max, so we just return max, skip, take. Okay, and next we call the function here solve of 0 m n and strs. Just a second. मुझे लगा इधर के value of path 0. Sorry, just a second. Yes, sorry for syntax. Yes, we cannot use recursion because see, we every string we had two choices. One is skip and one is take. Okay, so the tree becomes like in level 0. See, level 0 there are two calls. Okay, in level 1 there are 4 calls. In level 2 there are 8 calls. So in level 3 there are 16 calls. If total string is n, so total recursive call is 2 to the power n. Okay, so the time complexity is 2 to the power n, because every string create two branches, because every string create two branches. So recursion explore or subset many states repeat again and again, like see 2 comma 1 comma 1 also is repeated, 2 comma 1 1 they was repeating. Okay, so some state repeat multiple times, so it was slow. So for this we are going to use, so we can reduce time complexity for using memoization. You see, in recursion tree we saw same state repeating like this, recalculating. In memoization, store the answer, we store the answer. Okay, store answer, so we store answer of a state like I, m and m, just return. So we, if we solve once, we store this answer and we return the value, stored answer we are going to return. So there are no recalculation. So index I, so let's write a code. We just implement. First we create a map. String and int. Memoization memo. Okay, so m0, we create a key string in the string. Key is equal to 2 string string I place to string of m place to string of n. Yes, and next if we create to store the answer, if memo dot count key, so just return memo of key. If we see, we'll just return memo of key. Next, where is the answer? Just return memo of key is equal to max and time. Yes, so the code was right because of time complexity.